Clicking. Alrighty, and full screen. Alrighty. Number 5. Here we go. This is the second day of doing it because you guys remember all that first day stuff. Right? So the car's traveling at 50 kilometers, and it takes 2 hours to do that. And it says, what's the equation? What's the equation we're going to use for that?
Distance, velocity equals distance over time.
V is d over t, but if you're doing all super basic, they're just doing speed. So it's going to be draw this. It's going to be, I did the wrong thing. This is going to be S equals d over t. So you're going to have 50 over 2 equals 25 kilometers an hour. That was an easy one, right?
Yeah.
I don't know how to fast erase, so I got to do my eating worm or whatever.
You're an eating worm.
This weird. There's the typed out version of it, same thing. I'll post that to you later. All right. The car travels east, and then it goes back the other way west. And it says, what's the distance? This is challenging your distance displacement knowledge. How was the distance?
25.
It is Zoom fast math, all right? So 15 plus 10 equals 25 kilometers. Alrighty. And then displacement, a little bit different.
5.
It is going to be 5, right? So you have this one going that way and this one going that way. So overall, you're going to end up with 15 minus 10 equals 5 kilometers. So there's my nice little fast math there. Huh?
Would be negative and it's
It's positive. It's going east. That was plus. East. East is plus.
Oh, I see.
Oh, I thought you were saying
We should just call it.
I have a nice handy dandy drawing. You go red, and then you go blue, and that's the whole distance. But then displacement, you just go black. Number 7. Bird's gonna fly east, and it's gonna go north. Whoa, whoa! X and Y at the same time. Can't do it. What are you gonna do? Pythagoras is a triangle, right? So, it is a triangle. How far do you end up going?
5.
You do go 5 kilometers. All right. And then the last question out here, letter C.
You go 5 to the grain.
If you go 1 hour, that's a crazy circle. If you did 5 kilometers in 1 hour, what's your speed going to be? 5 kilometers an hour, right? So if I go to click and I go to here, it has all that right there.
Wait, but the distance, it went with that percent.
But then it said velocity,
Okay.
so you had to use the displacement, and this is the displacement. That was a good question. Nice. All right, ready for the next one? Any more questions on that one?
Not getting up like
No, sir. Okay, so it said how much velocity is 6 hours between both feet.
It would be the everything, yeah. Right now? It is, no, it's just 5. We did all these already. Oh, 8. 8. Whoa. How do you do that? Are you a ghost? Just in case you're wondering who said that ghost comment, her name is. I'm just kidding.
You can $80. I mean,
alrighty. What's the stuff that we have? What are the variables?
We have velocity and time.
We start at
0.
rest, so that's going to be 0. You're going to accelerate to 25, so that's how fast you're going to end up going. 25 meters per second. Acceleration is question mark, and it was 10 seconds. Please bring your volume down, peoples in the back areas. Use your whisper voices, please. Alrighty. With the formula number 4, right? That's the easy one we're going to do. You're going to have V equals V naught plus AT squared. No, it's not squared. There's no squares. That's a different equation. Alright, so then it's going to be 0 plus, no, that's not 0. Yeah, 0, yeah. No, okay, yeah, I'm doing things wrong. Correct me earlier, you guys. Yeah, but I still typing things wrong. 25 equals 0 plus A and 10. 10 times blank is 25. 2.5. So 2.5. Sir.
Couldn't you just do the change in velocity over the change in time?
That is what I did.
I know, but you did it like in the way.
Yeah. Alrighty. You ready for number 9?
Wait, I can't see if it's a can't read your handwriting either.
Here's the better handwriting way.
No, I got you. No, I didn't mean that. Like, sorry.
Gosh, you mean lady.
For the term. Your Majesty.
Alrighty, next one. Next one. Number 9. Car starts from rest. Same step as the beginning one, or what we just did. Accelerates at 5. This time we don't have the final velocity. They want to know it. And then they want to find out what the average is. So, how fast are you going after 5 seconds? Which equation would we use? The 4th one again, right? So, you are going to start at rest, and you're going to accelerate like this for this much time.
24.
Because we want the final velocity, and Formula 3 doesn't have final velocity in it.
What was the answer to number 8?
Meter per second squared. Alright, so this one you want the final velocity. You start out at 0. You're going to accelerate at 5 for 5. 25. So the final velocity is 25 meters per second. Using the same equation we just did. Do you want me to math that out? Is it okay?
Yes.
You do want me to math it out?
Yes.
The answer to that question is no, always be yes.
25. Alright, if you have 2 velocities, you have the V naught is 0 and the V equals 25 meters per second. Meters per second. Alright, if you're going to find the average of that, you take them and you add them together and divide by 2 because there's 2 of them. What's the average? The average equals. Is that easy? Like, you got that part? Acceleration, I mean, not the acceleration. The average velocity. That's what you would use for the x over t, but I just did the average of 2 things. So I did the average of the v plus the other v, divide 2.
You could find the distance.
You could do that way too, yeah. Multiple ways of doing things. I erase. There we go, get the worm going. The erase eating worm. I will learn how to mass erase later on. There's the Because there were 2 velocities. There was the start velocity and the finish velocity. There's 2. That is one way of doing it.
So that would be 25.
But 25 is velocity, not distance. We didn't need to. We did the easy way. The easy way is you take 2 things, you add them, and you divide by 2. There's 2 things.
Wait, why would it do that?
If you have a set of numbers, You find the average of the numbers by adding them up and divide by how many there are. So you have this one and this one. There's 2.
So you take average plus final.
No, you take your final and your start.
Why
Yeah.
would you divide by the number?
Because we were just doing the average.
But isn't the average the change in something over the change of something?
It's going to be the change in distance divided by the change in time.
But it was over 5 seconds.
Yeah, but we don't know the distance, so I was doing the other way of finding it. You have to find the distance and then use that. So I was doing the easy step way, hopefully. Sometimes the super basic math goes away from the smart folks like this, but we'll just bring it back. Just basic stuff is good. Alrighty, there is a part C of this question. There are 3 ways of doing this one. I was gonna do I was gonna do formula number 1 over there because we just got the average velocity, and then you're just doing velocity times time equals x. So v average equals x over t. We want x, so you're gonna do v times t equals x. What was the average from this a minute ago? So 12.5 times 5 equals x. That is correct.
You have it. I don't have it.
Would you like me to use a different method? Well, I'm about to show it to you anyway.
No.
I does. All right, the other method that I have on here is using formula number 3 right here.
I did that way.
That's formula number 3. That's so you have x equals v naught t plus 1 over 2 a t squared.
No.
That's an a. That is formula number 3.
I was there last
Are you all confident with that equation? So for that one, you just plug in 5 is the acceleration. You got 5 seconds. 5 squared is 25 times 2.5 equals the answer. And it's the same as the other way. So this is using the acceleration, and the way we just did a minute ago is using no acceleration. You find the average. All right, 10. On your paper it says 5. Change it to 10. Your paper says 5. Change it to 10.
I don't see 5.
It's on the back page.
I was hiding it from you on the other page.
Which one?
The one that says time. So it's 5 seconds, and I want you to change it from 5 to 10 seconds. 5 is what I don't want. Alrighty. So just to emphasize that one more time, I want you to change this number here in the PowerPoint so that it is 10 on your paper. Your paper says 5, the PowerPoint says 10. Now they match, hopefully. Okay. You start at rest. No, wait, you start from 20. You start from 20, and you're going to accelerate at 5 for 10 seconds, and then what's your final velocity? This is also using which equation? 4 equation, right? V equals V naught D plus A T. Yeah. 20 plus 5, 10 equals
70 more per square.
70, not squared.
Doing things ain't nobody ever seen.
Oh, okay. No.
Alrighty, easy stuff.
I forgot. I was like,
I get it, chick, because you got it right.
I literally like
Alrighty, here's the first practice for the quiz you're about to take in like 8 minutes. I don't know. Alrighty. So the ball is dropped from rest. That means that its starting velocity is 0. And if it is being dropped, then the acceleration is -10 because you're AP. And then we want to find out how fast it's going after 6.5 seconds. It is Zoom answers. Zoom answers over there. We did it. V equals V naught plus A. That's going to be a GT because it's gravity. And then so we have V equals 0 plus -10 times 6.5 equals -65 meters per second. That's for A. All right, B is how far did it go during all that time? And so you can do the 3 different ways. You can do Formula 1 if you found the average. You do that plus 0, divide 2, there's the average times your time. Or you can do the Formula 3, where you start out at 0, and then you're going to accelerate with gravity times 1/2, and then time squared. Or you can use Formula 5, and you can have your velocity and your velocity squared, and you divide it by velocity. So there's multiple ways. The easiest, I think, is finding the average, because you guys are very easy at finding the average, right? Especially if it starts out at 0. What's the average of 65 and 0?
32.5. And so whenever you find the average, it's always going to be positive, right?
No, it's negative. It's going down.
Okay.
Lots of
Every time I
things.
try to actually learn.
So V equals X over T. We have T and we have V. So we're going to do 32.5 negative equals X over 6.5 times equals.
Are we still doing A?
Yep. No, we're doing B.
Okay, so for A, which, are we using equation 4?
Yeah, we did.
So how do you know acceleration?
You know acceleration because it's the thing that's been dropped.
Oh, gravity.
Gravity is acceleration and a dropped thing.
So on the AP like, test,
It will be 10.
10. All right, you can go ask me.
Please stop your nonsense. Not you, sir. You, sir.
Is it 10 or negative 10?
Which way is gravity going?
Negative.
It will always be negative until we get to energy. Dot, dot, dot.
Negative 65.
What?
Negative 65.
There you go. Alrighty. In this case, the distance and the displacement are the same. Same quantity.
Wait, say that?
B and C are equal in this scenario.
Oh, okay.
Yeah.
Alrighty. Next one. This was a nice question for you again too. Erase. Line, line, line. Draw. What color should I use now?
Blue.
Blue. Light or dark?
That's good.
Alright. So we have a ball that's thrown down. It's going to be thrown down this time. VI or V naught is not 0. It's 3. But it's down, so it's
Negative.
-3. So when you see the quiz in the future, they're going to give you something is thrown down. The velocity is going to be negative because it's going down.
I know we did a problem last class where like down was positive. Why do you always specifically tell us that?
Nope, you get to choose. Dot, dot, dot.
We did a problem last
You
class.
to choose down, down.
Down was positive. And I thought they
I have
told
to
us.
count because everything is
But acceleration.
like we can't. Yeah.
It's true.
There we go.
Formula 4 again.
Argo.
We're going to.
So it's V equals V naught plus A T. V equals negative 3 minus 10 times 4. V equals negative 43 meters per second. That's the answer to A.
No.
Yeah. And then you want to know how far it went. You can do the average velocity way. This time I'm going to do the Formula 3 way. Move. There we go. All right.
If you did the first equation, you would
X
get 46
naught
minus
0 equals
plus G.
So it'd be negative.
So take the left one.
Oh, I didn't write the formula first. I will write the formula before I get going because you can't see it on the internet over there. So X equals X naught plus V naught T plus 1 over 2 A T squared. Oh my goodness.
It wasn't that funny. It was hilarious. Katie made a funny joke. I'm so proud of her.
X equals 0 plus negative 3 times 4 plus 1 over 2 negative 10 4 squared.
37.
What's 3 times 4?
72.
2-0.
Half of 10.
5.
4 squared.
Started.
5 times 16.
80.
80.
Negative 90. Ooh.
90.
The documentary.
Sorry.
Alrighty, that is a good practice for your little quiz there.
I don't. Wait, what was the answer?
Negative 92.
Like, literally, I'm ruining my life.
Doesn't seem very hard. It doesn't. It's just manipulation of words. You write down every
Plug and
Yeah.
What Miss Muller told us was from her algebra teacher who she had. We learned a lot of things. Like Miss Muller woman.
It needs chip in French.
Really short.
13.
Yes.
Alright, ball's going to be thrown up with a velocity of 30. This one is also very good for your future quiz.
All right.
Draw.
Wait, we can? I asked you that.
I didn't ever answer that because I didn't hear you say it.
I thought, well, I thought you were just, I was like,
She is a quiet talker
That's in the record.
without the facial expressions and everything.
All right, because there's no video.
It's videoing this as I point to the screen when I say this. Alrighty. Ball is thrown up with a start velocity of 30. Oh, all this stuff I got to erase down here too. Teal, switching to teal. Alrighty. V naught equals 30. I was talking about 4 seconds. V equals question. A equals negative 10. T equals 4 seconds. Per second squared.
So if they don't give you acceleration, it's gravity.
If it is a thing that's been dropped or thrown or something, yeah. You guys have forgotten how to whisper again. Yeah, that's good. Do that.
It's all coming together right now.
That's good. Alrighty. How fast are we going to be going after 4 seconds? I'll draw a picture.
Negative 10? I like pictures.
No, you really cheated for us. This is good. Should I actually do it? It's on my phone.
2. That's supposed to be the same height as that one, so I'm gonna fix that.
26.
Oh, pictures.
All right, the common thing that people mess up when I'm looking at this nice picture that I drew is that they are thinking that this is position. It's not. This is the velocities. So if you have the cool equation that we had before of v equals v naught plus a slash g t, gravity is how much? Negative 10, right? So negative 10. And then if the time was 1 second, what would be your change in velocity? It'd be negative 10, right? So every 1 second, you're changing by negative 10. So if I started at 30, after 1 second, I'm going to be at 20 because you subtract 10 every time you accelerate by 1 or every 1 second. So this picture that I have here is the visual representation of what's happening in this equation. Does that make sense there, right? Hopefully, I'm drawing it out, right? So you started out at 30. You started at 30, and then you went 20 and 10, and then at the top you're at 0, right? Right. I'm throwing a thing in real life so I can see it, but you can't see it. But like right there, you have a velocity of 0 at the very top, and that's what I have right here at the 0 at the top. And then it starts coming back down again because you're still accelerating always down. Gravity is always down, even when you throw something up. That's going to be one of the questions that people ask me on the quiz that I get all the time. But gravity is always pulling you down, even if you're throwing the thing up. They're not talking about while you throw it up, but after it leaves the hand, then gravity is down, pulling it down. So you got this thing, you're throwing it up, and then it goes up in the air. If you threw it up with a start velocity of 0, look how high it went. People always think that it always starts 0. No, it doesn't. If you start out throwing it as something, you're going to have some start velocity.
If you just drop it.
If you just dropped it, then it would have to be something else. Yes.
Okay.
Yes.
Wait, so you're the answer.
0 is not the answer. If you're counting in your time, they said 4 seconds, so you're at 1 second, 2 seconds, 3 seconds, 4 seconds. This one is the answer.
But you doing that mathematically.
But you could math it up here, yeah. So then you got a 4, which would equal negative 40, and then you started out with 30 plus 30 plus all of that, and you're going to equal negative 10. There's the math way. Is it okay if I erase some of my crazy drawing now? So this, and this, and this, and this, and this, and this. This.
When you were dying. I could tell, and you like trying to cough like I didn't help. I know.
It was totally me. I was just like, I totally thought it was.
Alrighty. Now we want to know where is it? We want to know how far is the distance from here to here, because that's how high it is. We got to figure out how high that is. So with our nice visualization, you can go from 30 to 10, or you can go from 30 to negative 10, and that would be the same amount of distance from where you started. Either way. Which way do you want to do? What it says in the problem? Let's do that. Okay.
I'll do me. Can I do me on the board?
You want to be the daredevil? Do it.
Yes.
Macintosh. You never heard that before? I've heard that's like the ultimate dare. That's a new thing.
Yeah, that's what I was thinking. It's not like you were trying to say Mazel Tov, but you didn't know how to say it.
Macintosh.
Yeah, that's what I Mazel Tov. See what? Oh yeah.
We have a student volunteer coming to do this one. Are you going to talk to, or do you want me to talk? All right. There's Snowball over there with the microphone.
It's 75 meters.
Is it?
I'm still at 3. And I found 3. And I found 3. And 3. These and these. These and these. And all of that. Yeah. That was
We got straws right
Okay.
That one?
I don't know. No, I do remember. No, I totally can do this.
Oh, it's negative.
Like happy but not really. Yeah, you're like you express happiness.
Is that correct?
Nope. Because so this equals 20. Divide 2 equals 10.
Okay, wasn't it?
So that would be negative 40.
I don't know if
Divide
that's
5.
necessarily sad. What's your average?
You're right.
Yeah.
But you're adding them together. So it's going to be 30 plus minus 10. So
Oh, so it's negative 10 plus, or negative 10 plus 30, or 30 minus 10. But aren't they both negative? Or no, 30 is
plus negative 10.
negative 10 plus 30.
I don't even know what that is. I was
Divided
like,
by
I think
2,
it's straight
20
face
over 2, which
stuff.
is 10.
20.
Wait, why do you think 30?
Because you start out, you have to find the average of your two velocities you had. And so the start and the finish, you had 30 and negative 10.
Your average is 20.
No, it's not.
Your average is 10.
There you go.
So it would be 40. No, you was missing 40.
It would be 40 meters.
But yes, and then I yelled.
Because your average is the start plus the final divided by 2.
Yes.
There we go. So I just messed that part up.
Yeah, that's the most common where it's going to go. Because there's a negative. You're getting a what? Oh, someone's trying to hang out with me?
All of us are.
Should I do it?
Yes. Oh, is this mine?
Yeah.
Hey, Rich, hang out.
I don't know how to do it.
I didn't say anything.
One person.
I think you got rid of it.
Oh, I just canceled it?
Yeah.
I didn't even need to cancel it. Alrighty. Now I'll clean all that up and show the answer.
Why is it 40?
Oh, I should have left my picture. What else? The picture is very good for your quiz when you're looking at it in the future.
So
I recommend.
can we do it again? Oh. What the heck?
That's one way to get past all the writing. Just move the whole thing.
Thank you, Tegan.
Much appreciation.
Was that,
Yes.
was that the display?
Yeah.
Alrighty. B and C are also the same, and actually, yeah, B and C are the same in this one also, because if it is right there from where you started, it's that far from the release point. That's the displacement and the location of it. So B and C are the same on this one also. Alright, 14.
I didn't get it. Can you go back to that? Yeah, can we go back to that one?
In a minute.
Okay.
This is like almost the twin of the one we just did, except for now it's 6 seconds.
Oh, okay, so it's the same.
Which is also an extra clue for your quiz that you're about to take in just a little bit. All right. So,
What?
What are you saying?
He said it's the same as B.
yeah, B and C were the same. They were
I think that's
twins.
just like a.
Oh, because like it just goes straight up and straight down.
Yeah. We're not doing projectiles until like next week or something crazy like that.
What?
All right. So this time you have the thing that's going up and coming down, and there and there and there and there and there and there. And each tick mark is a second, right? So you have 30, 20,
I figured it all
10,
out.
0, 10, 20, 30, negative, negative. And you got to count 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. So after 6 seconds, what's the velocity? We're not talking about it hitting there. We're talking about like right as it gets there. So negative 30 meters per second is the answer at 6 seconds. They're not talking about that it's hitting the ground. They're just saying it's in the air for 6 seconds. If it was in the air for the entire 6 seconds, at 6 seconds, it's going to be going negative 30 meters per second. As it would be, it might bounce or whatever, you know, so it might be doing some kind of other thing. But we're talking about all the way down right up until the instant that it's there. Not now, but like right as it gets there. The displacement is 0. Yeah.
Because it's the exact same.
Yeah. If you went up and came back down to your same spot, then you're going to be 0 displacement. Yeah, just like yo. I'm doing a lot of throwing action, but you can't see me because I was told that videoing that way is not as good as the other way. So I'm doing this. Displacement. Where is it compared to the release point? It is exactly where it started.
Okay.
And it says all that again right here in nice, pretty words that are in your PowerPoint that I'm sharing to you. It was negative 30 meter per second, and then it was 0 meters, and then it is exactly where it started.
So 0.
Uh-huh. Alrighty. This time you're throwing it up at 30, and you're going all the way until 8 seconds. 2 more seconds. In the picture,
So B and C are 0.
yes.
5.
7, 8.
You
7
said
seconds.
15 minutes left.
Seconds. 15?
Yeah.
We're doing good. We're doing it right with this. You get 10 minutes for the quiz. Perfect.
Oh, let's go. I'm gonna get 4. Are we doing C right now? One class.
Yep. That's supposed to be an S right there. That's not an S.
Displacement is 0. Relative to the thing is 0.
No, not in this one.
What was the relative point? It's 14.
Oh, I'm talking about for 15, you have 8 seconds, which is 2 more seconds than the last one. So it's like you're throwing it and you threw it off of a cliff.
Okay.
Like you have the thing and you're doing it like this.
What do you mean by relative to?
If I released right here and it went down there, how far did it go now?
From the release point.
So I want to know how far is this to this? What is that distance there?
Okay. But wouldn't there be some?
But you could just find B.
No, did you see how I did it? You got the thing, you're right here, you go like this.
So you're basically throwing it up and then whatever's underneath is not there.
Yeah, the hand moved out of the way.
You could do the average velocity and do like 50, negative 15 minus or plus negative 30.
Which is going to be?
Negative 20.
So A is negative.
You crazy adder. If you do 30 plus negative 50,
Wait, positive 30 or negative?
that's going up. That's positive 30. So then this top part is all divided by 2, and that's going to be 20 negative divide 2 equals negative 10 equals V average meters per second. That's not the answer. Does it ask for the average?
No.
All right. Well, A is this. This is A. B is how far did it go? We didn't get that part yet.
How am I supposed to do it?
What number are we on?
We're doing 15.
Oh, Brad.
We're doing 15. If you use your average velocity for 8 seconds, no, I don't think you can do that for 8 seconds. I don't know, maybe we can. We'll try it out. So I'll do it 2 ways and check my answer real fast. So negative 10 times 2 is negative 80, right?
This is weird, yes.
All right, and then I'll do the other method real fast, which is x equals 30 times 8 plus 1 over 2, negative 10 and 8 squared. 2 for O minus 5 times 64. What's 5 times 64?
Oh, God. What is that? 320
negative 240 equals negative 80. Nice! It worked.
All right. Well,
Wait, so B and C are the same thing?
No, well they are. They are.
So, how'd you get negative 80 right there?
On this one? This one?
Yeah, right there. You just.
All right. So my first set of math was find the average velocity.
Yeah.
And then I did, well, I guess I didn't show it. Okay, so V average equals X over T.
Okay.
So I took that and put it there. T is 8 seconds. And then this times that equals 80.
Why are you unsure if you could do it that way at the beginning?
Because I haven't been doing it very often, and I just wanted to check my answer.
Doesn't X just show distance?
X is displacement.
So then how is C the same as?
Because it from where it was released, it is that far down, and that's how far it went.
Wait, I thought we were talking about the displacement.
Displacement.
Wait, no, why